people were talking about pollution in cities like Shanghai, Beijing, Hong Kong. And people were coming up with good solutions. But nobody was talking about this: pollution from burning dirty fuels for cooking. Every day, the nomads in Western China were coming home to air that was 10 times more polluted than the air in Beijing. And across China, more than 500,000 people were dying from breathing toxic smoke from their stoves. And nobody had come up with a solution that worked. But the nomads had an idea. They wanted to be able to use the sun as a clean way of cooking. They had seen solar cookers before, but most of them broke within a few months and became ways to hold up walls or the tops of dog pens, of dog houses. So we began to import solar cookers from around the world and test them out, but none of them met the power, durability, and safety expectations of the nomads. So we began to build and test and build again. We built 13 different prototypes of solar cookers with 54 different variants, and we had a lot of learnings along the way. One of the first ones was about how to control solar focal points. With these types of technologies, previously, this point of light, which is where the heat and the power is, was uncontrolled. So when people were adjusting it to the sun, that hot spot was moving in a way that they couldn't anticipate. So people's sleeves were catching on fire. Their homes were catching on fire. Sometimes even their fuel piles were catching on fire. So we ran many, many different tests. And finally, we found a way of attaching the reflector to the base that controlled this phenomenon and kept that hot spot always right here underneath the burner, just like in a conventional stove. And this was a big breakthrough, making people feel safe to use this type of technology. Another one was reflector durability. And there were a couple things involved in this. Previous versions of this type of technology used mirrors pasted onto the top with an adhesive. Now that adhesive didn't hold up particularly well in high V conditions and the various other environmental conditions found in this region. So within about 3 months, all the mirrors would fall off and people wouldn't be able to use it at all. So that was one. Two was that people in this region are primarily herders. So in order to protect their herds, they're using slingshots against the wolves. So if a slingshot hit the reflector and it was made out of glass, the entire thing would shatter. So we started to think about, well, what other types of materials could we use? And most plastics didn't really work because you had UV problems, you had temperature problems. We're talking about a region where it gets down to negative 40 degrees Celsius in the wintertime and then up to about 30 degrees Celsius in the summer. So it has to go across really wide temperature variations and also very, very high UV conditions as well. So after trying out many, many different types of materials, we finally realized that we had to develop a material of our own. So we spent a very long time on this, and we were banging our heads up against the wall. And finally, I heard about an engineer and material scientist down here in Hong Kong. He had retired to a life of windsurfing. And I went and I knocked on his door, and I told him about this problem, and he joined our team, and within a few months, we had solved it and developed a new material that has, I think, become the best performing material in this sector in terms of solar reflectors. I'll talk a little bit more about that later. Another one was weight and portability. The nomads told us that they wanted a system that was portable, but what exactly did that mean? Our first sets of systems that we put out weighed 3 kilograms, 5 kilograms, 6 kilograms, and they looked at it and they said, that's just going to blow away in the wind. We don't want a system like that. And so we started to delve into this situation more deeply. And it turned out that anything less than 15 kilograms, they felt would just fly away in the wind. And anything that was more than 50 kilograms, 50 kilograms, was too heavy because that was the amount of wood that they carried each day, wood or dung. And so we experimented in that range, 15 to 50, and we found a great system at 18 kilograms. So right now, even though we could be a 3 kilogram system, we're an 18 kilogram system. Another is comfort and safety. Previously, these technologies were a complete dish, and in order to cook with them, women had to lean into the front. Now, that had two problems. One is that it blocked the sunlight, so it reduced the power. Two is that it exposed the women's eyes to high levels of UV radiation. So we did something really simple, which is to cut a V out of the back to enable women to stand behind the reflector and cook in a way that was safe and comfortable. Now, you might think that this decreases a lot of the power, but actually it doesn't. Because when you're working with this type of a system, where does the light fall? It falls here. And the types of cooking that people are doing in this region are boiling, steaming, frying, types of cooking that require the sunlight to all be on the bottom of the pot. If you're looking at this area, which is above the pot, light can't bend, so you're never going to get it below. So it's not actually a very big loss. And then, after all of these different learnings, all 54 of them, we finally arrived at a system that people did like to use, and that was the sole source. Our reflector is greater than 90% energy efficient, and it's the only reflector in the world that's 3D formable, which means that we can achieve the perfect geometries for concentrating solar energy instead of having 2D shapes. The reflector as well is very scratch resistant, so it's withstood more than 10 years of accelerated weather testing, including sandblasting and UV and humidity and temperature. And that's really important because this region has lots and lots of sandstorms, and so do many of the other regions where people can benefit from this type of technology. Our customers in Western China tell us that not only are they able to cook a wide variety of foods on this technology and use it for more than 2/3 of their cooking operations, but it's able to save up to $50 per month for them because of money that they don't have to spend on fuel. So that's a pretty cool thing, and we're really excited about it. And that's not all. The sole source is also sustainably manufactured and 100% recyclable. Because of that, in 2012, One Earth Designs became the first company in China to be B Corp certified for using sustainable practices in every aspect of our business. And in fact, we earned the highest B Corp score ever awarded. So we're really proud of that.